Factoring trinomials when a equals 1. So what does that mean? You have a polynomial. It has 3 terms. That means it's a trinomial. If you want to factor it, you're saying what two binomials multiply together to get to this trinomial. So if we want to factor, we first need to know what our a value is, which would be 1 here. Our a value is just what is in front of our squared term. Our b value, which is what is in front of our linear term, and our c value, which is our constant. In order to factor, there are lots of different ways, but one way involves multiplying your a value times your c value and saying what two numbers can multiply to get your a times c value that add up to your b value. So let's check it out. Our a value is 1 and our c value is a positive 10, which gives us 10. Our b value is 7. So what factors of 10 add up to 7? So we have 1 and 10. We have 2 and 5. 1 plus 10 gives me 11. 2 plus 5 gives me 7. So ding, 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 ding. We found them. Once you have those two numbers, I can create the area model. Some people also call this the box method for obvious reasons. In our area model, it's essentially saying length times width gives us the area. So what times what would give us the area? So we can kind of work backwards. We have the area and we need to figure out what times what gets us that area. So we start by putting in our x squared term, top left. Our constant in the bottom right. And then we found these two wonderful factors over here, and those are going to go into the other corners. So 2x and 5x. Once we have this is our area. If we added all these pieces together, we would get our polynomial, our trinomial. But if we could figure out what the length and the width are, so what multiplies to get all these individual pieces, we can figure out the factors. So let's pull these factors out. We want a common factor of x squared and 2x, and that would be just x. A common factor of 5x and 10, which would be 5. A common factor of x squared and 5x would be x, and a common factor of 2x and 10 would be 2. So check this out. If we're working the other way now, x times x gives me x squared, 2 times x gives me 2x, 5 times 2 gives me 10, and 5 times x gives me 5x. I'm going to take these pieces and write them as binomials. And those are my factors of this trinomial. So if it just said factor, I am all done. I can multiply them together to check my work. But what if it said to solve, which means what values of x would make these work? So when you're doing that, you're saying, if it equals 0, what would each one of these be? Well, according to the 0 property, that means one of these would have to be 0. So let's set them equal to 0. X plus 2 equals 0. X plus 5 equals 0. Subtract 2, subtract 2. I get x equals negative 2. Subtract 5, and I get x equals negative 5. So if I was asked to solve, I have negative 2 and negative 5 as my answers. All right, so let's try another one. My a value is again 1. That's what we're working with. My negative 8 here is my b value, and a positive 12 is my c value. Over here, I'm going to list my factors of A times C. So 1 times 12 would give me 12. And my B value is negative 8. So what multiplies to 12, that adds up to negative 8. So I would have 1 and 12. I would have 2 and 6. And I would have 3 and 4. Well, 1 plus 12 gives me positive 13. 2 plus 6 gives me a positive 8. And 3 plus 4 gives me a positive 7. So we got to think of something else here. I see that I have an 8. 2 times 6 gives me a positive 12. But doesn't negative 2 times negative 6 also give me a positive 12? And negative 2 plus negative 6 gives me a negative 8. So when you have a positive term for your A times C, you could also make them both negative. And if your B value is negative, that's what it would have to be. So negative 2 and negative 6 are my two numbers. I now create my area model. Boom, boom. I put my x squared top left. I put my C value bottom right. And I'm going to take my negative 2 and my negative 6, and I'm going to put them in these two corners. Now I'm going to pull out my common factor. My common factor of x squared and negative 2x is x. My common factor here of negative 6x and 12 is negative 6. My common factor of that row is x, and my common factor of the bottom row is negative 2. So I write my binomials, x minus 6, x minus 2, and I have factored. Boom! If it says to solve, you're saying it would equal 0. So I would put them both equal to 0. And solve. And I would have x equals 6. And x equals 2. All right, let's try one more example. If you think you have a handle on this, you might want to pause this video. See if you could do it on your own now. If you still need a little help, follow along. We have A times C. That gives me 1 times negative 15, which gives me negative 15. My B value would be a positive 2. So I need something that multiplies to negative 15 that adds to a positive 2. Well, if my value is negative, one would have to be positive, one would have to be negative. If my B value is a positive 2, that means the bigger absolute value of the number would have to be the positive number. So for example, if I have factors like 1 and 15, 15 would have the biggest absolute value, so that would be positive, this would be negative. I would have 1 and 15, and I would also have 3 times 5. Negative 1 plus 15 gives me a positive 14. Nope. Negative 3 plus 5 gives me a positive 2. Ding, 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 ding. Yep. All right. So now I'm going to make my area model. I have my x squared. I have my negative 15. I take my negative 3x and 5x. And now I rock that area model. Let's pull a factor out of this column. It would be x. And a factor out of this one, which would be 5. Common factor out of this row would be x. Common factor out of this row would be a negative 3. So I have x plus 5, x minus 3. Those are my two factors. I can multiply them together, and it would multiply to get this trinomial. What if it said to solve? I set each one equal to 0, and I solve it. All right. If you can get those three so far, good for you. You can shut this down right now. Let's take it a step further. So if you're ready for it, one step further. You should notice that my a value here is not 1 this time. It's 2, which means that I could have a GCF. So I could have a common factor in each one of my terms. If that's the case, we are going to factor that out, divide it from each term. I can divide this by 2. I could divide my second term by 2, and I could also divide my last term by 2. So 2 is the GCF. I'm going to divide them all by 2, and I'm going to rewrite this. Those cancel. Negative 16 divided by 2 gives me negative 8x, and negative 40 divided by 2 gives me negative 20. So now it's exactly like what I had earlier, but just has a 2 hanging out in front, and that's fine. So my a value now is 1. My c value is negative 20. So 1 times negative 20 gets me negative 20. And I need it to add up to negative 8. Factors a negative 20, and it has to add to a negative b value, which means the bigger absolute value of the numbers is going to be negative. So it would be 1 and negative 20. That gives me negative 19. 2 and negative 10. That gives me, ding, 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 negative 8. I can stop there. I can keep going if I wanted, but there's really no need to. I found my factors. We're good to go. I rock my area model. Boom, boom. I have an x squared. I have negative 20. I have 2x, and I have negative 10x. I pull my common factors from each column. So it would be x and negative 10. Here would be x and 2. X minus 10, x plus 2. And we can't forget that this 2 we pulled out as the GCF. So if I just had to factor, I am done. If I had to solve, again, I would put each one of these equal to 0 and solve. All right, y'all, go try some practice problems.